All right, so this week, or starting today, the plan is I'm going to work on the information that goes along with the additional of transformations. Uh, it's the very last additional transformations and reflections. Now that I'm saying it, I don't know exactly. Rigid transformations and congruence. Okay, there's what we're looking at. And so by the time we finish this, we should be able to perform these transformations, and then we could be able to describe which one took place. So I want you to look at these vocabulary words really first. A transformation just means something changed. That's all that means. A translation. So the translations. Let's say I have this square here, and I took this square and I took every point on the square, which would be these four right here, and I moved it all, say, 9 units right. Well, by doing that, the square never changed sizes, it just moved. That's a translation. Translations are told by either moving 9 units left, 9 right, 10 left, 10 up, 2 up, 2 right. So you're just moving it around. Never changes the size of it, you're just moving it around. All right. The reflection, which is the next word in your vocabulary over there, is like the mirror image. So that's saying, like, here's this, and it's on a coordinate plane. And let's say I wanted to reflect it across the y. That means I'm going to fold it, and it would be over here. Or I'm going to reflect it across the x, and it would be down here. Again, nothing changed sizes, nothing changed the shape. All we did was shift it over to the other side. Okay, so you have to, main thing on reflections is paying attention to, does it say reflect y or reflect x? And so it's just a mirror image of that. And I'm not sure if you just heard someone screaming in the background into my microphone. My son is playing PlayStation while I record this video, and he just did something well and screamed really loud. All right, the next word is rotation. So rotation, again, we're looking on a coordinate plane, and you'll see things like rotate it 90 degrees clockwise or counterclockwise. So rotate, and usually it'll say, most often what we see is it'll say about the origin, which is there. So if I had something, say, here, and I'm going to rotate it 90 degrees clockwise, it's going to look like this. Or if I was going to rotate it 90 degrees counterclockwise, it would move down here. Okay? So it's just shifting it, but you have to think about visually what it's going to look like. Now, again, out of these three right here, the translation, the reflection, and the rotation, okay, those three right there, nothing changes size. Everything exactly the same. So if I know that, say, the size of this side right here is 4, when I translate it, it's still 4. If this is a 90-degree angle here, it's a 90-degree angle here, and it's a 90-degree angle here. Nothing changes. Now, the one where something changes is the dilation. A dilation is, let's say I had a line, okay, we'll do the L shape right here. Okay. And I was going to dilate it. Actually, we'll go ahead and do a rectangle. And I was going to dilate it about the origin on a scale factor of 2. Well, I would go to each coordinate. So this one is -2, 2. So the new coordinate for this is going to be -4, 4. This one was -2, 5. So it's going to be -4, like 10. Everything's going to get multiplied by 2. -4, 5. So that's going to be like -8. Oh, excuse me, that should be up here. -8, 10. And this is -2, 2. And so that's going to be -4. or no, negative, sorry, negative 4, 2, I can't see hardly. So it's going to be over here. Okay, but anyways, the shape did grow, and it grew at a scale factor, meaning we enlarged everything. So to figure that out, we're looking at what did we multiply or what did we divide by? Okay, now that was a whole mess of stuff, but it's easier if you just see some of these on some actual questions. I'm literally going to use questions from here. Okay, so quadrilateral ABCD here is dilated about the origin, and it turns into quadrilateral EFG. Now, here's one thing you need to know about this. A corresponds with E, B corresponds with F, G corresponds with C, so on. So the new one is going to have G at 16.8. Ooh, well, 16.8 is going to be like somewhere, over here. So that means this C got stretched out all the way over here. Well, here's the first thing I'm going to look at. I'm going to look at how do I know that I'm dealing with the C? Because the C was the third letter, the G was the third letter in the name. They correspond. So I'm going to look at this C and go, well, it was at 8.4. Right? It was at 8.4, and it moved to 16.8. So we're looking at what is the scale factor? What happened to this? Right? And everything was multiplied by 2. Because 8 was multiplied by 2, 4 is multiplied by 2. So I can figure out the rest of them as well, because this was 2, 8. This is going to become 4, 16. It's going to be somewhere out here. Everything's going, all these dots are going to get multiplied by 2. It's going to look the same shape, but just be a different size. And so if I'm looking at what the scale factor is, and I'm going to adjust this one, because it actually should be this, because it's a scale factor of 2 to 1. Okay, because it was multiplied by 2, it grew. Okay, and I'll fix that. I just can't do that right now. All right, let's look at another question. Okay, rotated 90 degrees. So we saw a dilation. We looked at the coordinate plane, we looked at the ordered pairs, we could see what it was multiplied by or what it was divided by, and what the new one would be. Okay, this one we're doing a rotation. So we're going to spin it. And we're spinning it around the origin. And we want to go clockwise. So that means the way that the hands of a clock go. Okay, so we're going to rotate it 90 degrees. So let's do that. If I rotate this 90 degrees and spin that, okay, looking like something like that, then it's going to translate down 9 units. So now it's going to be down here somewhere. And then we're going to reflect it across the y-axis. So this shape is then going to go over here somewhere. So I'm looking for something in this third quadrant because I had to do all of these. I had to rotate it, translate it, and then reflect it. So if I look at my choices, I'm looking for something that's in the third quadrant. It's not that one. It's not that one. That one. Okay? You can see how it's the same shape, it's just spun around differently, and it landed here in the third quadrant. Okay, so same thing here. We're looking for a reflection. Now, when you look for the reflections, you look at what's it over? Y. So I'm going to fold across the y-axis. So everything's going to be a mirror image. So I can even see that this is going to be this is at -3, so it's going to start at 3. It's going to go to 4. It's going to go up to here. And like that. It should look like that. That's the mirror image, exactly how it should look. Okay, and so if I look for one that looks just like that, well, there it is right there, first one. Okay, and let's see, I'll give you 2 more questions. And I'm going to do the first objective today and the second objective tomorrow. Okay, triangle ABC is dilated about the origin with a scale factor of 2 into triangle. You see those little marks? That just means it's a new triangle. What will the coordinates of point C be? So here's point C now. Point C is at -3, 1. And I'm doing a scale factor of 2. So guess what? I'm going to multiply everything by 2. Or I have those backwards, don't I? You should have told me that. This is 1, -3. There's my parentheses. It's hard doing this because there's 1, -3. So if I multiply all this by 2, that becomes 2, -6. Boom. There it is, right there. All right, so there's you give you an idea of what those transformations are. So you're going to have like 5. I'm going to give you 4 or 5 questions that I want you to answer. Here's the plan this week, and I'll have this in writing as well. Today I'm going to do objective 1. Tomorrow I'll do questions on objective 2. Wednesday and Thursday, for those who have not passed it by then I want you to do like we did last week, and I want you to schedule a Zoom with me so that we can work through it. You may pass it by then, and you don't have to do the Zoom Wednesday and Thursday. But if you don't, then we'll do a Zoom either Wednesday or Thursday on your schedule to take care of that. And this will get that last additional that we didn't get a chance to cover in class. But I think you should be able to handle that. All right, good deal.